Good morning, everyone. Welcome to another video from Advanced Math Tutors. Today, I want to bring you some example problems on how to use U-substitution to solve certain integrals. And remember, if we want to take the derivative of a function that looks like h of g of x, then by the chain rule, we know that this is equal to h prime of g of x times g prime of x. And so if we have an integral that looks like this, then we can just use fundamental theorem of calculus to find its antiderivative, which would be this. And so what U substitution is it's a way to undo the chain rule. Typically, you would set U equal to g of x, and then du would equal g prime of x dx. And so if you had to integrate something that looked like this here, what you could do was say, okay, we can just substitute g for u and then du for g prime, and what you would get is an integral of h of u du. And then hopefully that h of u is easier to integrate than the first function. And so let's see if we can use U substitution to figure out the answer to these integrals. Now, in this first one here, it looks like we have a u and maybe a du, even though the derivative of x squared is 2x. If it just differs by a constant like that, you can still use U substitution to work around it. So I want to show you how to do that. So here the argument of cosine is x squared. We can make that our u, and on the outside we have an x, just an x, not a 2x. But let's just see what we can do with it. So here we have u is equal to x squared, and therefore du by implicit differentiation is equal to 2x dx. And now we can use a little bit of algebra to work on this du. And the reason we're going to need some algebra is because we don't have this 2 here. This 2 does not appear in the integral, so we're going to have to work around that. But we can do it. So let's say we have du is equal to 2x dx. So if we bring the 2x to the other side, we now have du over 2x is equal to dx. And so what we can do now is we can just substitute dx in for dx in the integral. And so if we do that, and we change everything to u, we'll now have the integral of x times cosine of u. But now we're replacing our dx with du over 2x. Du over 2x. And as you'll see, the x's will cancel. So this x will cancel with this x, and we're left with an integral of only u. So this becomes the integral of just cosine u du over 2. But now this 1/2 here, we can just pull that out of the integral because that's a constant. So this is equal to 1/2 times the integral of cosine u du. And we know the integral of cosine u, it must be sine u. So we know that this is equal to sine of u. And of course, we bring the 1/2 in because it's a constant. And now let's bring everything back to in terms of x's. So remember, u is equal to x squared. So let's just substitute x squared in for u, and we get the answer, which is sine of x squared all over 2. And that's our answer. So even if you have a function and its derivative, but the derivative is off by a constant, like how we didn't have the 2 in this problem, you can still get away with using U-substitution. And we're going to have a similar situation over here in this problem. Here, it looks like, well, we have 2 options, because the derivative of sine is cosine, but we don't have just a cosine, we have a cosine squared. So maybe u equals sine wouldn't work. Let's try u equals cosine. U is equal to cosine of x. Not cosine squared of x, just cosine of x. So if we do this, du must be equal to negative sine of x dx. All right. And now it looks like what we have is we can rewrite this integral as cosine squared. That just becomes u squared. And now this sine of x dx we can replace with a negative du, because if we look at this equation right here, we can see if we multiply both sides by -1, we'll have negative du is equal to sine of x dx. And so sine of x dx is exactly what we have right here. So let's just replace that with negative du times negative du. Well, that -1 is just a constant, so we can pull that out of the integral. And what we have is -1 times the integral of u squared du. And we know what the integral of u squared du is. It must be u cubed over 3. So this is equal to -1, because it's a constant and it comes through, times u cubed over 3. And now let's just substitute what we know u is. Remember, u is equal to cosine of x. So when we do that, we substitute cosine of x in for u, and we get negative cosine cubed of x over 3. And that's our answer. Oh, I forgot, plus c. Since we are dealing with indefinite integrals, there will also be a plus c down here as well. All right. And thank you for watching the video. If it helped you out, leave a like and feel free to subscribe for more.